Okay, so warm up. On your 18th birthday, you deposit $10,000 in an account that pays 5% annual interest, compounded continuously. How long will it be until you have $50,000 in that account? Okay, so compounded continuously has a special formula, and that formula is called PERT. So the amount of money you will have will equal to PERT. Okay, so A equals PERT. The principal amount is what? What is the principal amount? $10,000. $10,000 is the principal amount. E is 2.71. The calculator knows what E is. R is the rate, the interest rate, which is 5%. 5% is 0.05. Times T. T is what we're trying to figure out. How long? How long will it become now your investment 50,000? So your output A must be 50,000. Okay, so we're trying to solve for T here. So this is just an equation we're trying to solve for T. How do we solve for T? We got to get rid of everything else and get that T to be by itself. So I think I'm going to get rid of 10,000 first by doing the opposite of multiply, which is divide. I'm going to divide it by 10,000 on both sides. 10,000. 50,000 divided by 10,000. What is that? 5. 5. So 5 divided by 1 is 5, and we got e to the 0.05 t. So now I got to get the letter T by itself. What's the next step? What's the next step in getting the letter T be by itself? So in elementary school, we learn basic equations of solving, say, 2x equal to 10. What do we do to get the x by itself here? Anybody? Divided by 2. So you know that. That's elementary school math. Say x plus 10 equals 20. What do I do here? Minus 10. You don't even need to think about that because your brain spits it out. It's easy. But what do we do here? This is what I'm supposed to teach in Algebra 2. How do we get the T by itself? So we're going to come back to it, leave some space. We're going to come back and solve it in a minute. So we're out here stuck. Let's go ahead and do this lesson, and then we can go back and solve it. Go ahead and copy this down. Let's review again how to solve how to graph exponential functions. This is an exponential function, y equal 2 to the power of x. And let's remind ourselves how we figured it out, how it looks like on a graph by doing a table. And you got input and outputs. Input x, and I chose these numbers because they're in the origin close to it so we can graph. And then we got these inputs to get these outputs. So for an input of -3, it must have an output if you plug it into the function. X is -3, so we got 2 to the -3 power. Worked out, you work this out, and that would give you the output. What is 2 to the -3 power? Somebody is saying it, what? Is it 1/8, everybody? 1/8? Yes? It's 1/8. 1/8. So that's what you're supposed to remember, and we practice it so much, and I don't want to talk too much about it. 2 to the 3rd is 8, because it has a negative. It's going to be a fraction, 1/8. So you get 1/8, then you get what? 1/4, then what? 1/2, then what? 1, 2, 4, 8. and we graph these points on the graph. And it looks like a ramp. Okay. So, what is the inverse of an exponential function? That's the question. What is the inverse? Like we had in elementary school, you learned that the inverse operation of multiply is divide. Inverse operation of subtract is add. The inverse operation of an exponential function will be this. Let me show you how we came up, or whoever came up with this. Maybe he came up with it like this. He said, switch the inputs with the outputs. So from the exponential function, switch the inputs will become the outputs, and the outputs become the inputs. What do you mean by that? Well, it means this. The y becomes the x, and that x becomes the y. And when you do a table of it, just switch all the outputs to become the inputs, and the inputs become the outputs. And then we plot the points. So when I say y equals 1/8, see how I change the colors? The inputs become the outputs, and the outputs become the inputs. Y is 1/8, and then x is -3, right here. Y is 1/4. These are become the inputs, which is weird to say that this is the inputs and these are the outputs. 1/4. The input is 1/4. The output is -2. Input 1/2. Output -1. Input of 1. Output of 0. So it looks like this. And the other one looks like this. And so you could see that it is a reflection about y equal to x. This is y equal to x. So if you were to fold it, they land on top of each other like this. And so they are inverse functions. So this is how the actual function is called a log function. And this is how it goes. Log. Look up the top. I have it there. Log. The base is 2. Log base. This is base 2. Log base 2. Log base 2 of x. This is the actual equation. Log base 2 of x. So we say log base 2 of x is y, is equal to y. That's the equation. So y equals log base 2 of x is the inverse function of the exponential. So now this is called y equals log base 2 of x. So how does it go? You switch the inputs with the outputs and then rewrite it in log form. Log function is the inverse of an exponential. And you say, well, how does that help me solve the warm-up? We'll do it in a minute. I'll show you how. It's actually the calculator that does all the work. I'm going to go ahead and move on, and you can go back to the video and copy things down or go to the website, but I'm going to move on here. Okay, so now that we know that y equals log base 2 of x, and a log function looks like this, It always goes through the 1, 0. This is called y equals log base 2 of x. So you should know transformations. This should be now very straightforward. What happens when you add 4 at the end of a log base 2 of x function? What's going to happen? Anybody? It's going to shift it what? Up what? Up 4. It's going to move up 4. So this is a good reference point. 1, 2, 3, 4. And then you're going to get this log function going something like this. Something like this. Something like this. Alright? So shift it up 4. How about that one? Number 2. Okay, here's a very good thing here to recognize. This particular number, problem 1, it has a base 2. It's telling you log base 2. But this one over here doesn't have a base. What do you think is the missing number that should be there? Anybody? It is not 2. What other number could it be? What base do you think it could be? The calculator only knows a base what? The calculator only knows a base 10. It's automatically a base 10. So if it does not have a number, it automatically is 10. Alright? So that function is a base 10. But it still follows the same shape of a base 2. It's been shifted what? Up 2, down 2, left 2, or right 2? Right 2 is correct. It's been shifted right 2. So shifted right 2 units. So the parent function will be shifted to the right 2. So it's going to move to the right 2. This point is going to move to the right 2. The bigger the base, the faster it goes to the right. So this thing is going to go to the right even faster, like this. It's going to go like this. Something like that. The bigger the base, the faster it goes to the right. Something like that. Moving on, I gotta go. Continue on. This is a base 2, log base 2. It has 3 transformations. Whenever you have a negative in the front, it's going to be reflected about the x-axis, shifted to the right 2, and shifted up 3. So when you graph it, it's reflected about the x-axis, shifted right 2, up 3. Okay, so if you have the parent function, y equals log base 2 of x, and you do all these transformations from left to right, you got 3 of them, reflected about the x-axis will look like this. Something like this. That's a reflection about the x-axis. Then we're going to shift it right 2 units. Right, I'm going to use this as my reference point. Right 2 units. And finally up 3 units. I'm going to use this as my reference point. Up 3 units. 1, 2, 3. And my final answer will look something like this. Something like that. And I erase all these other transformations, and there should be the final answer right there. There it is. Problem number 4. I'm moving on. You can go back to the website, get the notes. 4. Problem number 4. Y equals ln x plus 3. Y equals log base 2 of x is the particular graph, which is still the same almost as y equals log base 2 or log base 10 of x. It's just that this one goes faster to the right. Y equals ln x is a special log where its inverse function is y equals e to the x. So e to the x, so the base e, ln has a base e. So these are inverses of each other. They're special. So ln x is the inverse of e. But still the shape of it is still the same as log. So if this is y equals ln x, which follows the same I said as log, y equals ln x, pretty much the same. Y equals ln x is shifted up 3 units. 1, 2, 3. Same thing, nothing changes. Looks like that. All right, what is it useful for? What is it good for? Well, it's good for if you ask somebody something like this, a question like this: 7 to the y power is 20. 7 to what power is 20? 7 to what power is 20? Well, with logs you can get the exact answer. The answer should be between what? 7 to the 1 power. 7 to the 1 power is 7. And then you got 7 squared is what? What's 7 squared? 49. So pretty much I know that the answer is between 1 and 2. Why? Because 7 to the 1 power is 7 and 7 squared is 49. 20 is between 7 and 49. But what exactly is the answer? 7 to what power is 20? Here we go. Let me show you. This is how it goes. You're going to put it in log form. And we're going to go like this. Log. What's the base? Log base 7. Log base 7 of 20. That's how it goes. Log base 7 of 20 is equal to y. There it is. And your calculator is going to do all the work by putting it and changing it to it's called the change of base formula. It's going to go like this because the calculator only has a base 10. So what I'm going to say is this. You're going to split the log. One log on top, one log at the bottom of a fraction. Put the big number at top, 20, and put the little 7 at the bottom. And that's going to give you the answer by putting it in a calculator. Come up and get a calculator to learn how to use the calculator and get the answer. You guys see the log function is the second button down on the calculator here on the top. Log. You're going to hit log 20. Log 20. Get a number. What are you getting? Log 20. Get a calculator. Log of 20. What are you getting? 1.30109299. Divided by log 7. Log 7. What are you getting now? Approximately what? 1.5 what? 395. So the answer is 1.5395 approximately. How can you verify this that the answer is correct? Go back Get your calculator and go 7 to the power of 1.5395. 7 to the 1.5395 power. What is that? 7 up button, 1.5395. What are you getting? 19.99999. Isn't that close to 20? So now we got that y approximately. Let's do this number 5, everybody. Let's practice some more. Look at this number 5. Log base 3 of 15. What is it? What is it asking? 3 to what power? 3 to what power is 15? 3 squared is 9. 3 to the third is 27. The answer is between 2 and 3. But what exactly is the answer? You're going to put it in a calculator and then 1 log on top, 1 log at the bottom. Put the big number on top, 15. Put the 3 at the bottom. And the calculator will do all the work. You're going to do log 15 divided by log 3. Log 15. Get a number divided by log 3. What are you getting? What are you getting? Log 15 divided by log 3. Put it in the calculator. Huh? 2.4, 2.46. 5, but it's raised, what's that? Round up? Go ahead and do what? 3 to the power of 2.465. What is that about? Go ahead and do that. 3 to the power of 2.465. What are you getting? 15.004. It's, yep, this works. So this is working out. About 2.46 will give you an approximate solution. All right, let's go to the warm-up and get this done with. On your 18th birthday, you deposit $10,000 in an account that pays 5% interest compounded continuously. How long will it be until you have $50,000 in the account? Now we can solve it. Here we go. I am not going to use LOG. What am I going to use? I am not going to use log. What am I going to use? What am I going to use? Natural log. Because natural log is the inverse of the base E. So I'm going to use ln base E of 5 is equal to this whole thing here. ln base E of 5 is equal to that. How do I get the t by itself? Now, how do I get the t by itself? How do I get the t by itself? This is simple elementary school math. Divided by what? 0.05. So the calculator again automatically knows that the base is E. There's nothing else but E. I'm gonna even erase this thing. So all you gotta put in the calculator is ln 5 divided by 0.05. That gives you the answer. Get a calculator. The third button down, ln 5 divided by 0.05. And the answer is what? Approximately. So if you deposit $10,000 in an account that pays 5% annual interest compounded continuously, how long will it take for your investment to reach $50,000? 32 years. That's pretty good. So 32 years. So if you give them 10,000 at the end of 32 years, they give you 50,000 back. Is that a good deal? I don't know. All right, so that is it. We're done. Stop.